Hello everyone, and thank you for joining the chat room for a METS showcase on new processing and new opportunities. I'm Rob Coleman from Core Resources based in Brisbane, and I'm joined by three other Queensland-based companies. We have Bjorn Zikarsky from Pure Battery Technologies, we have Verboomen from Sorterra, and Michael McCann from Lava Blue. So welcome to you all. Before we get started, just a reminder on the format of the session. There'll be a discussion for around 20 minutes, followed by 10 minutes of questions. Please submit your questions during the discussion using your question box, and we hope we'll get through all of them in the allotted 30 minutes. Okay, so we'll get started with just a brief introduction to each of our panelists and really the new processes and technologies that they are currently delivering and to which market segments. So I'll start with you, Bjorn.
All right, thanks Rob, and thanks for TRQ for supporting us on this platform. Hope you guys are having a good conference. I represent Pure Battery Technology. I'm Managing Director and CEO. PBT, in short, is an Brisbane, Australia-based company specializing in producing nickel and cobalt compounds from intermediate products and recycled metals. So we process MHP and recycled metals. The vision of our company is to be a leading nickel and cobalt refiner and recycler for the EV industry, and with the lowest cost of production and significantly reduced environmental footprint that is based on our proprietary technology. Our mission is to demonstrate cost leadership using our patented technology, environmental leadership. We have demonstrated that our footprint is very, very small compared to alternative processes of converting MHP into battery-ready material. As such, we want to attain a reputational leadership using that innovative Australian technology in support with the Oz Industries and others in this rapidly growing and significant industry. And obviously, I'm mandated by my shareholders to provide economic leadership, rapid commercialization of our technology to build strong revenue, profit growth, job creation, and significant exports. What we've done to date, we have proven up our technology. We've built a small pilot plant. We completed a preliminary feasibility study, which is not longer preliminary. It's quite advanced to process 25,000 tons of nickel in MHP into a nickel sulfate and an NMC product. We gauged interest with significant industry players, upstream as well as downstream, suppliers, customers, and investors. And we have identified and we're in the process of purchasing and redeveloping a site for production, for immediate commercial production within the next 3 months, basically. In Europe to create our footprint there. We do have a collaborative business model. We are a company that has a technology without an asset in the ground. We have upstream strategy, and we have downstream strategies. And this is all out of this forum. Probably it would break the time that we have, but it's a snapshot of our company. Thank you very much.
Thanks, Bjorn. Jan, maybe you give a bit of an introduction to Sorterra.
Yeah, thank you, Rob, and thanks for TRQ for the opportunity. Sorterra is a young technology company, so we develop technology and then we also build the plant and then commercialize worldwide. We've got an experienced board with people that have plenty of experience in the mining industry, and then the technological founders who have got a lot of experience with the core technology that we're applying into our system. We've built a power plant, which we tested some months ago, or some years ago, I should say, at our Coleman site. All the learnings of that plant have been incorporated in a new plant, which is ready to go on site in the next couple of months. And from here, we will start commercializing the equipment. First one is meant for the coal industry, but obviously we're looking at other type of minerals as well, whether it's base metal, precious metals, or others. That will be in the next phase as we grow the company. Thank you.
Thanks, Jan. And maybe just confirm that it's ore sorting technology.
That is correct, yes. Yeah, that's correct, Rob.
Okay, thanks. And Michael, if you can give us a briefing.
Thanks, Rob. And just to clarify something Rob said at the introduction, we're actually perfecting an old technology. We're not really developing a new one. Lava Blue's focused on developing a scalable process for high purity alumina production, I'll just quickly explain high purity alumina for anyone who hasn't encountered it before. HPA at 99.99% pure is now being adopted for use in ceramic coated separators to improve the energy density, discharge and recharge rates and temperature tolerances in, at the moment, lithium ion batteries, but works in other battery architectures. So it's a very demanding mineral. It's an oxide, obviously. It's not actually a metal, and it has particular attributes required as in these electrochemical applications. Lava Blue is an unlisted public company. We're actually a minerals developer. We have mineral properties in North Queensland. HPA is the first cab off the rank for us. We're a bit earlier stage in both Bjorn and Jan, in the sense that we've been in the lab for 18 months, getting to understand exactly what we're making, how to make it, and the parameters that have to be controlled to deliver to particular specifications. The HPA market is actually quite immature. The uses for HPA, the specifications for end users are still developing. Different battery separator makers and different battery makers are still literally experimenting with the properties, the attributes that HPA can bring to their battery architectures. We've designed a mini plant. Now, when I say mini plant, it's not a scale up from our lab. It's what we expect to be. It's a sort of a scale down from what we expect our first production train to look like. The mini plant will test the materials of manufacturing, and it's designed to feed a machine learning harness so that we can understand all of the thermodynamics and kinetics and chemical reactions involved to control the processes throughout the process, from the first time the raw material, which is a kaolinitic assembly of clays, hits the leach tank through to the crystallization of the final product. The mini plant is designed to be a long-term industrial test bed. It doesn't just turn on and run. It actually gives us a basis on which we can experiment with various parameters to produce different product outcomes. So Lava Blue has other mineral properties, including high purity quartz and manganese, but at the moment we're investing in demonstrating the HPA processes that we have perfected in the laboratory.
Right, thanks, Michael. So we've got a range of different companies here, from producers that have something in the ground to technologies and to actual pieces of equipment that can go into process plants. So a wide range of companies. So maybe I'll just start the discussion with a question around what kind of changes do you see happening in the industry at the moment? Maybe if you just focus on Australia, and really how does your technology contribute to that change? So maybe Michael, you can kick off.
Yeah, thanks, Rob. Well, so Lava Blue is essentially a company where the executives have come from an energy sector background, and for various reasons, we've ended up in what we now broadly refer to as energy metals or energy minerals. We think that the energy minerals space is the perfect storm for Australia, and as evidenced by Australia's leading role now in the supply of lithium, production and supply of lithium products around the world, there's a bunch of other minerals which, as electro or energy metals, will have different requirements and and present the opportunity of a high degree of refining onshore. Production of energy metals will be very exacting. The specifications are different from the sort of metals that you can buy through the LME. And as we're discovering with HPA, which is particularly demanding in terms of purity and attributes, a lot of end users have different specifications. Now, because of that, because of the value adding, because of the end value of the products and the quality controls required, we think, in a sense, small is beautiful, sort of. That's a very relative term, small, but small, efficient systems, processes, and plant that can deliver exacting specifications for particular end users. It's an enormous opportunity for Australia. The electrification of everything, which is the thematic that we're dealing with, it's not just EVs, it's stationary storage as well, and it's small mobile devices up to large devices. So the electrification of everything is opening up a new world of minerals for Australia, and lower capex, lower technical risk, higher return opportunities present across the board. As for instance, Bjorn's work, particularly in the cobalt and nickel sulfates, we see there's huge opportunities here for Australia to really reach down the value supply chain and deliver products of very high value.
Can I add to that, Rob?
Yes, please go on.
So I'll cite there with Michael that the value add is certainly changing. Australia is used to or has a history of exporting bulk products, and all these small metals that can be processed in a certain way and value added are coming more and more to the forefront. So overall, the picture is changing, especially with the electric vehicles or just mobile devices, etc. A lot of other minerals are much more in demand than bulk ore, bulk iron ore, and bulk coal, and maybe copper and gold. And so we see a shift in that advanced manufacturing, advanced processing will have a much bigger footprint. It's different for each mineral or for each metal. For example, nickel and cobalt doesn't enjoy richness necessarily in Australia. There's plenty of nickel and plenty of cobalt, but there's other areas in the world that you have high grade material. And so we see it a combination of either advanced products being exported out of Australia or simply technology being exported. In our case, it's probably a combination of both. We see ourselves building plants with our technology overseas as well as in Australia.
Okay, thank you. Jan, anything to add on that from your perspective?
Yeah, so our technology can be classified, like you said before, as an ore sorting technology, and where we see the benefit, or can split the market in two if you want. So the energy, the coal, and both metallurgical and thermal coal, where the purposes of what we're aiming to achieve with our equipment is actually reducing the ash, but without the use of any water. Water being a scarce resource, and quite often coal mines are in areas where water is not available or difficult available, and then if you wash it, you've got tailing dams or whatnot. So if we can process it dry, there's a definite added value by doing it that way. On the other end, so when we're looking at different types of minerals, and let's take copper, for instance, as an example, the grades are reducing worldwide, so it becomes more difficult to extract the copper out of the mined material. So what we're aiming to achieve with our equipment, again, in the dry matter, is reducing or pre-concentrating the material so that the downstream processing becomes a lot cheaper and more added value to it. So it's a two-phased approach, or two different approaches to different industries, but ultimately the same result, getting a better quality product out without using water.
Okay, great, thanks. And also just a reminder to anybody watching, if you do have any questions, please post them through using the question section on your screen. Maybe we'll just go then into a little bit about kind of what new opportunities do you see emerging for Australia, and really where do we need to move to in order to manage those opportunities in your areas?
Well, I'd like to pick up actually as well where Bjorn left off, and it's inherent in Sorterra's approach too, that indeed developing these processes for highly refined electrometals, and that leads to other opportunities as well, biomedical applications, all sorts of emerging applications which require high purity minerals and metals of particular properties. The opportunity in Australia is to do this work here because we're very good at it. We have the minerals and we have the regulatory settings to allow us to do this, and we have an appetite in the investment community to back new processing. And then, as Bjorn said, is to the small, lean, low capex processes and plant are easy to export to license into other locations. And so for Australia, it does present both of those opportunities to become a leading supplier in particularly high value minerals, and to export our IP and our technology. We're already a major source of minerals and mining expertise around the world in terms of wetware people, and there's I see increasing appetite for investors in Australia to back new processes, and that's really heartening.
And can I add on further there, Michael? Thanks. When we're not playing ping pong here on purpose, by the way, but we just happen to be having the same approach. I think this whole advanced manufacturing or advanced processing certainly is a split between upstream and downstream. There is upstream strength in Australia, and there is a lot of downstream opportunity. Unfortunately, manufacturing is no longer as relevant in Australia as it used to be. For our industry, for example, making batteries for cars, I think we just dismantled the automotive industry, so it's kind of inappropriate to talk about making batteries in Australia, I think, and they will be made overseas, but it doesn't mean that we cannot have a major play in that or provide input into that one, and that's what we're kind of focusing on. So it's a little bit of a split that people have to make, and there are going to be new skills that need to be deployed, and both understanding upstream and downstream, and engaging, obviously, on many, many levels. Then there's geopolitical movements right now, whether the whole supply chain goes into China or out of China, or whether that has changed, and whether this whole onslaught of COVID regulations and changes in how you do business might affect that. So it's an interesting playground for our industry, where we are providing nickel and cobalt products for battery making for NMC material. It's simply like we have something that we can help be a cost leader. We can make the batteries cheaper for everybody, and if we can contribute to that, then everybody is better off.
Right, thanks.
I think from a technology point of view, Rob, sorry, from a technology point of view, I think there is a need that we all have to look at further developing, not like a change in a minor change, but step change in technology to the ever more difficult minerals to be able to extract them and refine them. And that's going to be definitely a challenge that we all have to work towards, just so that we can add that value here in Australia, rather than having to do it somewhere else, or even make it just economical to extract the minerals that we're after.
And you mentioned about the advanced manufacturing. So, as your companies, do you feel that you get much grant support through the government, or you're able to get funding? And how have you been going about getting funding for your projects to push them forward?
Well, on that note, I have to say Lava Blue's got an embarrassment of leverage, and thank you for TIQ for backing us into this. But we've got currently more than $1 million dollar for dollar matched grant from the Innovative Manufacturing CRC, focused on the machine learning processes, which allows for modular flexibility in your process train, so you can use the same equipment essentially to drive out different products. I don't think the COVID-19 rethink of the structure of the Australian economy has hurt people who are working in advanced manufacturing. I think the prospects for us look good. Just to reiterate one more thing, again, playing ping pong with Bjorn, is that the upstream and downstream opportunities in Australia, and the impact on supply lines of the recent sort of global reshuffle, means that efficiency in everything is critical. So it's efficiency in capital, water, as Jan was talking about, energy, obviously, because we're moving into a carbon-constrained world, and smaller processing plants means you can have shorter supply lines on possibly smaller ore bodies closer to the end user. The big plants which process material and send them all over the world, well, they've got that weakness, long supply lines.
Bjorn, did you want to comment on grant support and government support?
Oh yeah, look, we're a proud receiver of Accelerate Commercialization Grant, and we also on a CRCP, where we have been partnering with the University of Queensland and with Cronimet Group, which is a large nickel recycling company out of Germany. So we're very thankful for that. I have to say that the Australian government is doing best it can. Enhanced manufacturing in Townsville, for example, is big on the agenda. Queensland is putting a lot of money out to promote value add processing and things like that. But I also need to be observant in saying that if I apply for a grant of 1 million here, I apply for a grant of 10 million in Europe. So the amount of support, especially for electronic vehicle supply chain development, is significantly bigger in other countries. But that's because they have much bigger economies. So we'll make a split here too. We try to maximize the support we can get out of Australia, but we're not shy of asking for support in Europe because it's an expensive exercise.
Okay. Yeah.
That's absolutely right, Bjorn. Developing new technologies is a very expensive exercise, and targeted assistance from both investors and governments, whether it's federal or state government, is invaluable to actually make it to a success. And it's a long process, and both investors and governments also should be aware that down the track there could be some failure as well. Not necessarily of an entire project, but people, or when you develop some new technologies, you come across hurdles, and it takes them a longer time to find a solution for it, and it costs also more money. So in the same vein, like what both Michael and Bjorn have said, we've been lucky to get good support to continue the development of our system. Although in earlier years prior to Sorterra, we had some black snow, as they call it. So it's a long game. It's not something that comes to fruition in a very short period of time. So that's something that hopefully everyone can appreciate.
Okay. So yeah, to everybody still listening, please send through your questions. We'll carry on with our discussion. So I guess, where do you see into the future your market segment or your minerals in, say, 5 to 10 years, and how is your technology going to meet that specific need in the future?
Well, I'll start, since we've been running around the table in this direction. So for lava blue, particularly the high purity alumina market is diversifying in both the specifications required in battery applications, but there are also wider applications developing. So the material itself is going through a bit of an adoption curve, and we're following closely how people are starting to use it. We have been fortunate to get a site at Redland Science Park in Brisbane, which will be right next to the National Battery Testing Facility. So we'll be able to fabricate separators of our own and have them tested. So we expect to see ourselves just working closely with battery developers as well as battery manufacturers to ensure that we're delivering materials that are suitable to their needs and do improve the performance of batteries. Jan was talking about providing value-added materials to battery manufacturers around the world. I think there is a very good chance Australia will be hosting more battery manufacturing itself. Townsville clearly has got advanced, at least feasibilities underway, and some significant investment. And Kwinana, with the support of the federal government, the West Australian government, and a number of companies there, including the Future Batteries Industries CRC at Curtin, is also looking like a hot prospect to host pretty sizable investments. So I am hoping, from Lava Blue's point of view, that we'll be able to enter into supply lines with new manufacturers and not necessarily have to go in and displace existing suppliers into the existing markets.
And Rob, we're on the same page there with Michael. We're not looking to muscle in. This is an expansion market, so we want to create new manufacturing capacity with new technology. And I like Michael. I like your use of the word hotspot. I'm gotten careful about that one the last few days. But
good point.
What Pure Battery Technologies is doing, how we see ourselves contributing in the mid to long term to this market is very simple. We have a global based patent that we know creates great cost efficiencies, and we are educating our potential partners, investors, and suppliers along those lines. Our goal is we're focusing nickel cobalt for the people that in the know. We focus on the cathode side of the battery. It's the biggest amount of metal that goes in the battery, and battery has somewhere between 200 to 400 pounds of NMC material in there. And if we can attain our goal of shaving $1 per pound of NMC material being processed off the price, then that we have a chance to make a battery, the cost of a battery reduced at maybe anywhere between 5 and 10%. And it's a big statement. It's our goal. It's not what we're claiming that we can do. It's just that that's what we're aiming for, because everybody else is aiming at reducing the cost of batteries. And only if we can reduce the cost in an environmentally sound and safe manner, will we be able to proliferate the use of electric cars, which apparently have a tremendous benefit from a global perspective.
From our perspective, we're looking at, sorry, Bjorn.
No, you go ahead. I'm sorry. I was just want to say I was finished. So.
All right. So from our perspective, we're aiming at assisting both junior and existing mines to beneficiate their material, their feed material in a more economical, environmentally friendly way by not using water or using less water in cases of coal, but also for other minerals. Do pre-concentration, reduce the energy consumption, reduce the water and chemical consumption to actually extract the minerals that the company actually wants to bring to market. It's not processing yet 100% of the material, but it's like we're doing a good section of it, of course, as part of the material. And then down the track, hopefully we can develop technologies that also allow us to do the smaller size fraction so that we can offer 100% dry processing option.
Great, thanks. So we've got a question from the audience. What role does machine learning and AI have in exploration technology and for new processing? So, any comments there, Michael?
Well, machine learning's got extraordinary potential, particularly in our application, in being able to leverage our process design to produce different products, well, the same product with different attributes. So the number of parameters that we control in the crystallization phases of the high purity alumina, require us to have very close controls on the process and high degrees of quality control on the final product. And what we're aiming to do with the machine learning is to understand every step of the process and be able to intervene early in the process to achieve particular outcomes and avoid undesirable outcomes. So certainly in designing new process controls, they present opportunities for a great degree of flexibility.
Nothing to add from me. That was
from our perspective, there is an opportunity there to actually work or have the equipment learn what the quality of the feed material is and then what the desired quality is. And by using AI, the opportunity is there to actually come to a position where we don't need any operators for the plant. Of course, there's an initial learning phase in it, but once we go through that learning phase, then there's definitely a possibility to have the machine working as a standalone.
Okay, great. Well, we're almost coming to the end of the session. So I don't know if anybody would like to add any final comment before we close off. No? Okay. So I think the forum will be recorded and should be available for the next week, and then it's going to be, I think, converted into YouTube. But I'd just like to say thank you again to TRQ for giving us the opportunity to hold this forum, and then to Michael, Bjorn, and Jan for participating in the forum and for your valuable insights into new processing and new challenges going